All right, we'll be looking at scientific notation and significant figures. So what are these? So we'll be able to establish the relationship and also how we can solve questions based on that. So one thing that you need to understand is that scientific notation are used when chemists, people who study chemistry, even physics as well, when they have large number or small number. So we'll be expressing those numbers in scientific notation, or actually specifying just the number of significant figures which are important. All right, for example, let me give an example of what I'm trying to say here. So when you are given, let's say, a number with the all right, suppose you are given a number 6 point, or just 6, um let's say, let me write something like this. We have, let's say, 602, okay, 20000, all right, 00000000000. All right, so this number, we can count the zeros. Suppose these zeros, they are 23. It's as good as you writing this number in scientific notation, because this actually comes from Avogadro's constant, where we say 1 mole of anything, 1 mole of anything, okay, it contains this number of particles, molecules, or ions. All right, so is that easy to list all of these? No, the answer is no. So it will be as good as us writing this number in the scientific notation, which is 6.02, okay, times 10 to the power 23. Suppose there are 23 zeros there ahead. So this will be number of atoms. Okay, so we mean now 1 mole of a substance, 1 mole of a substance will be giving us 6 point that number of atoms. So scientific notation, this is the way of writing scientific notation. So we'll be expressing these numbers in this form. All right, so that's why this scientific notation plays a important role in this actual study of chemistry. All right, so that is it. So let me now go through with you like how we write this scientific notation. So scientific notation will always be given as, all right, n there, okay, where we have n, then that n multiplied by 10, okay, 10 to the power n, and where this n can be a positive or negative number. All right, then where this 10 is the number between 1 and 10, so it is between these numbers, so where n is between 1 and 10. All right, so for example, let us do some example. All right, example. All right, example. So suppose now you are given to express the following. I'll just write questions. Express, I just found it from past paper. Express, okay, express 568.762 in scientific notation. So how do you express this in scientific notation? Alright, so you express in scientific notation the following as, you want just a number here. We said this n is the number between 1 and 10, so you always try to list one number ahead there, which is in the range of 1 to 10. So times, then 6. So you bring this point in short, 1 2, you have moved it twice, okay, to your what, to your positive. All right, because you are moving to your from positive, okay. So when you go like that, then that means it's like that, okay. So you have moved it twice, so this means that you have 68762, all right, then times How many times have you moved that? It's that times what? 2. Alright, it's more like times 2 now. You have 2 on top there. Alright, so that means that you have moved, when you multiply this number times 10, the point should come this side again. Okay, so it's more like what can I say, for you to move this point. Alright, what can I say, so let me say we have 2.23. okay, this number can be written as 1 over, so that can be 223 over 1000 there. So you bring that one in line with the point like that. Okay, so this number, this 10, can be as 10 to the power negative 2 because it was over. So this is what we mean there when you move that point like that. Okay, so when you divide that number again, it still give you the point there. Alright, so that means when you divide that number, it will give you the same point. Let me say divide 223 divided by 100. That would be 2 points. So what we are trying to say is that point, when you go to the negative like that, you are increasing the negative. When you go to your positive like that, you are increasing the positive. So that has moved negative 2 like that. Okay, because we can reverse this by saying okay, 0 0, then the point will come there again. Okay, that's the meaning if we are to divide that. Okay, that's the meaning. So you multiply that times 10 to the power negative 3, you go back. So you say 5.6876, 5.6, let me say 5.68762. Then you divide by 10 to the power negative 2. Okay, so that will bring the point to the original. So that's how you can write that number. So by doing this, you can even, like, if the number of significant figures are specified, that's where now you can just write 5, let's say, to the 2 significant figures, then 2 times, anyway, that would be now 7. I'm sorry, like we are specified, let's say, to 3 significant figures, 3 numbers, so that will be 6, then there we'll have 9, then times 10 to the power negative 2 like that. So that's how you can write that. So another question, and let me write another question. Okay, so another question is, write the following in Santic notation. Okay, so how can we write this, the following in Santic notation? Suppose we have 0.00, okay, 0 again, 0 0, 772 in Santic notation. How can we write this? So you have seen this negative there that is on top there, so we are going to move those zeros. And how do we do that? We'll move the point, so we'll say okay, that will move 1 2 3 4 5 6. Okay, it has moved to the positive side, so the power will also be positive. So because the number line is like this, here we find the positive, here we find the negative. So if you move like that, you're increasing the positive. We move like that, you're increasing the negatives. So that will be if we have moved 6 times, so say the point will be there, all right, and that will be 7 times, 0.72 times 10 to the power negative, positive 6, because when you multiply this, it will still give you the same. All right, you have moved from negatives, right? So when you multiply that, okay, so that will be negative 6 like that, because you are coming from negatives. Okay, so if you are going from negative to positive, then you change. I'm sorry, by the way, here when you are coming from negatives, like you are coming from this side, you go this side, you carry what you have started with. But when you are coming from this side, you go this side, you carry what we have started with the positive. So that's what we mean. So when you divide, you multiply this again, it still give you the same. All right, that's the meaning there. Okay, so that would be negative 6 that will be the scientific notation you express. Okay, so you can do a lot on this one, but what you need to do is make sure that you don't forget how you have moved the point. If you're from negative, you go on positive, you carry that negative. So if you're from positive, you go like that, you carry that positive. Okay, so that's what I can say. You can do a lot. They are very simple, these ones. Let's go to something important, and that is significant figures. So significant figures. Okay, what are these significant figures? These are numbers that are relevant in the given expression. So suppose we are given, let us first do some rules, okay, of these significant figures. So the first one is zeros to the left are not significant figures. What I mean is, when we have zeros, 0.08, let's say liters, these zeros to your left, they are not significant figures. Therefore, this one has one significant figures. Okay. Then the other rule that we can talk of is, again, I can give an example there. Let's say I have 0.0000, all right, then 34 grams. These are not significant figures. The zeros are not significant, so this one has two significant figures. All right, so the other rule that we have is, if a number is less than 1, okay, if a number is greater than 1, so if a number, let me do this, if we have a number, first number as greater than 1, so let me say this is the second rule. So if a number is greater than 1, okay, so if a number is greater than 1, then all the following zeros are significant figures. I'm talking now to the left, to the right side. So if a number is greater than 1, then all zeros are significant figures. So all zeros are significant figures. Okay, so example, if you have a number 2 point, that's why this number that is here is less than 1, but here it's greater than 1. 2 point, let's say 0 mg or milligram. So this has how many significant figures? It has 2 significant figures. Okay, that's what we mean there. And again, numbers between, zeros between numbers are significant figures. Suppose I have 2, okay, 2 point, let's say 2.00, this has 3 significant figures. So again, numbers between zeros are significant figures. For example, but before I give that example, let me give another example of this type so that you don't get confused. Suppose I give you 3.040, okay, let's say decimeter. So this, so long as this one is greater than 1, then this is a significant figures. So that will have 4 significant figures. Okay, so that is it about this. I said, like, numbers between zeros, between numbers, zeros between numbers are significant figures. For example, 0.0, 4 point, let's say 0.62. These are significant figures because they are between numbers, so they are counted. So 2, 4, 5. So this has 5 significant figures. Okay, that is it about rule number 2. Hope you are getting there. And put this into practice, please. All right. So let me lab this. So that is it. So the other part, the other thing you can talk of is when we have, this is now the third rule that I'm giving you. So when you have, if the number is less than 1, is that what I was talking about, like the first case? Okay, for example, if that number is less than 1, so meaning that that number can be 0 or negative something. So if a number is less than 1, then only only zeros at the end are significant figures. For example, if I have 0.09, okay, 0, only these are significant figures. So this has 2 significant figures. All right, so that's what I mean there. Again, if I have 0.01, let's say 0400420. Okay, this has how many significant? It has 3. You only consider these ones if a number is less than, so it has 3 SG significant figures. So again, I can give an example to say if I have 0.3005, okay, this one will have how many significant figures? Numbers between zeros, zeros between numbers are significant figures, so this will have 4 significant figures. So that's how you can tell. Then again, the other thing we can talk of is trading zeros. Trading zeros, we mean zeros that follow each other consecutively, but for that, let me call it rule number 4. Okay, so trading zeros may have or not have significant figures. For example, if I have 400, how many significant figures are there? This can be 1 significant figure, 2 significant, or 3 significant figures. So how do we do that? So you can handle to avoid the confusion. Yes, you can say it has 3 significant figures, but that's what you can say, but it's still confusing. All right, it is still confusing. So what you do is you don't just write that, like they might not be significant figures, so you forget them. All right, instead, if you want to express that, let's say it has zeros. We said zeros between numbers are only considered significant figures, so you can only express this one in 1 significant figure. So you can say 4 times 10, okay, to the power 2. Okay, so that will be, we'll have 1 significant figure. Again, you can write this as 4 point, because it's greater than 1, then 0 there times 10 to the power 2. That will have 2 significant figures. Again, you can write that 4 times, so that's how you'll be expressing, that's how you'll be giving answers to such as, to avoid the ambiguity. So let's say 00, all right, times 10 to the power 2, that will have 3 significant figures. So that's how you express this. Okay, let's do some exercise to see whether we have understood this. Okay, so exercise. Okay, so the first thing that we have is, how many significant figures does the following number has? Okay, so we have 4, 78 centimeter, 78 centimeter. Then again we have 6.01 grams. Okay, so we'll find the significant figures. The other one again, we have 0.825 centimeter or meters. Okay, the other one we have 0. Okay, this will be now 0.0304. These are question papers, by the way. They are the questions from question papers and tutorial sheets. So then the other one we can talk of is number 5. Let me give number 5. We have 1.310 times 10 to the power 22. Okay, atoms. So how many significant figures? We'll look at that. So then the other one is, okay, the other one we have is 7,700. Input 7,000 mils. Okay, then the other one is okay, that is it. Let me just talk about this. So first thing, the first one has how many significant figures? So you can count, these are all just significant figures. This is very simple, and it will have 3 significant figures. Okay, so this has 3 significant figures. Then what about this one? Numbers between zeros are said to be significant figures, so you count them, all of them, so that will be also 3 SG. Then numbers that are trading like that, they are significant figures. So if equal, this will also have This one is not considered, so this will be 3 significant figures. So what about this? Only 2 are significant figures, right? Is that true? Yes, so we consider these zeros are not considered, not until there was a number here, or when they are in between, or when they are after a number like that. So that will be 2 significant figures. What about this? You look at what is just between 10 there. That will be your significant figure. So here there are how many? There are 4. So we'll say this has 4 significant figures. So coming to this now, this is where we said it has an ambiguity here. So what you do is you can either express in 1 significant figure, 2 significant, or 3 significant. So the first one you say, okay, 10 times 10 to the power 3 there, muse. So that will have 1 significant figure. So again, we can write this times 0 and times 10 like that, because 0 is now between a number. So to the power 3 like that, so this will have 2 significant figures. Again, you can write this again times 0, 0, then that will be times 10 to the power 3, that will have 3 significant figures. And again, you can write that to the power 0, 0, 0 times 10 to the power 3, that will have 4 significant figures. So that's how we can express this one. Express it in this form, please, whenever you have. Otherwise, you can only say it has 1 significant figures, but it has a lot in actual sense. So that's how you avoid the ambiguity like that. So let us do some more examples. So for example, how many significant figures does the following number has? How many significant figures does the following number has? So we have, let's say, 17,006. So this, you can see zeros between numbers are significant figures. Therefore, this will have how many significant figures? 5 significant figures. Okay. So what about this one? When we have 13,007,00, do we consider these as significant figures? No. So you only consider these as significant figures. So that will have 5 significant figures. Okay. So that is it. So let's talk about now when you have a number greater than 0. I mean, we looked at this when this is greater than 1, so that will be considered as significant figures. So this number will have 3 significant figures. Alright, so that is it. So again, if we have, let's say, 0.0, now it's less than 1, so only numbers that are zeros that we'll find ahead, that will be significant. So let's say we have 3, 0, 0, alright, then 1, 5. You only consider these numbers that have zeros between, so that will give you 5 significant figures. Okay, so what about when you have 404? This is where I said this is the ambiguity, like you have, let's say, 0, 0, 0, 0 there. So this has, you don't consider these zeros, please, unless if you express in the form I taught you. So now we have numbers between there, so we'll write this as 3 significant figures. Okay, so the other thing that we can talk of is, again, let's say we have zeros, 0 without a point there, 0, 0, 5, okay, 0, 0, 3, 2. These are not significant. They are not important. Significant, something that is important. So only these are significant figures. And how many are they? 2, 4, 5. So there are 5. So this will have 5 significant figures. Okay. So the other one I can give again is, suppose, okay, suppose you have again a number to say 5. All right. 5 0, 0, 3.1. So long as these zeros are between numbers, then they are considered to be same. These are significant figures, all of them. So this will have 6 significant figures. So 6 significant figures. So what if we have 0 point, no, let me just say 0 0.012.001. So how many significant figures are there? So you can check. This number is not a significant figure, so you only put numbers that are in between, zeros that are in between in that case. So this will have 5 significant figures. Alright, So the other thing that we can talk of is when you have, I mean, which scenario? I think I've given all the scenarios, but let me give this one: 6000, then point, no, point 00. This number is greater than 1, so it will embed all these. So this will have 6 significant figures. All right. Then again, I've been repeating the same case: 0.005 0 1 3 2. So this will have, we only start considering from here, which will have 5 significant figures. All right, so that is it. So those are the things to consider. Otherwise, significant figures are not like, just keep practicing. Like, look at what I've been explaining. Watch the video, rewatch the video, and you see what actually it will pay off. All right, so this marks the end. Thank you very much.